Hello everyone, welcome to part 2 of my video series on statistical significance testing. So today we are going to talk about different types of testing. For example, parametric versus non-parametric, paired versus unpaired, one-tailed versus two-tailed. Now many of the times you are going to encounter these terms, but you are not going to understand what those things mean. And also when you choose some test for statistical testing for a particular problem, you need to sort of understand like which type of test it belongs to so that you can actually choose the correct test for your testing. So let's begin. So let's start with parametric versus non-parametric. Let's take the simple problem that we took in the previous video. So suppose we collected height of 1000 Bangladeshi men and 1000 Bangladeshi women. The question is, are BD men significantly taller than BD women? And then maybe this is the data. You have the data of men right here, the height, and the data of women right here. So what is the parametric approach here? Now there are different types of parametric tests. So z-test is one of them. There is also t-test, Pearson correlation, etc. For this problem, let's actually see an example of z-test. Obviously, we are not going to go into the details of z-test here because that's a separate video. But here I'm going to sort of give an example of z-test to make you understand what the parametric approach really is. So first of all, in z-test, we have to assume that both set of heights for men and women come from a normal distribution. That means we have to assume that the data points actually come from a certain distribution. The next thing is using the data that you collected. So you collected the data of 1000 men and 1000 women. Using that data, you are going to compute the distribution parameters, which is the mean and standard deviation. If you have been following my lectures, you know that I have a lecture on normal distribution. And in that lecture, I talked about mean and standard deviation, which are basically the parameters of normal distribution. Now, each different probability distribution has different parameters. So when you assume that distribution for data points, you have to estimate parameters of that particular distribution. So the thing is, if you want to calculate the p-value right here, that is if you want to see if you can reject the null hypothesis, then you need to test how extreme the heights of one group are compared to the other based on the estimated parameters. So suppose we have estimated the parameters of the normal distribution of the men heights, then you are going to have to see how extreme the women heights are compared to the parameters of the men height normal distribution. That's it. So, I mean, the men and women height distribution can look like this. This is just a hypothetical image. And you can probably see that, but yeah, I mean, maybe it is an extreme case, right? Okay, so there are some advantages and disadvantages of parametric approaches. For example, this approach can be very powerful, especially if your data points actually follow the distribution that you assumed. But if you don't know about the distribution, then this is not so powerful anymore. And it is less robust to outlier data points. Okay, so what about the non-parametric approach? So you can solve the exact same problem of BD men height versus BD women height using a non-parametric approach, which is the Wilcoxon test. So this is one type of non-parametric test, and there are many different kinds of non-parametric tests which we are going to go through in details throughout this series. So just to put things in perspective, in such a test, there is no assumption regarding any particular distribution. So it's a distribution-free test. That is number one. And number two is, because there is no distribution assumption, there is no parameter calculation from the collected data. So no parameter is there. And number three is, most of these tests actually deal with ranks or orderings of data points in each group. So in BD men height group, you can sort of rank the heights. In BD women height group, you can also sort of rank the heights, and you can sort of see which ranks are actually extreme, right? So you sort of compare the ranks of one group against the other and see how, what should I say, how extreme one ranking is compared to the other. And based on that, you sort of get the p-value. So that's basically the approach of non-parametric approach, basically. So it is applicable when there is small amount of data points collected, extremely important in bioinformatics, because in bioinformatics, often you are not going to have a lot of real biological data. It depends on the resources. So if you have a small amount of data points, this kind of test is the one you should be looking at. And also if you have higher abundance of outlier data points. Now outliers will be there more abundantly when there will be a small amount of data. I mean, those two things are sort of correlated. And finally, if you don't know which distribution to assume for each group of your data points, then obviously you should go for non-parametric approach. So that is one way you can classify the statistical tests. Another way is you can classify each statistical test as either one-sided or two-sided. So let me explain what these two terms actually mean in terms of statistical testing. So suppose, again, we collected height of 1,000 BD men and 1,000 BD women. Now we can ask three types of questions here. One is, are BD men significantly taller than BD women? So this is a one-sided test because we are saying significantly taller. That means it's in the positive side. Or you can say that are BD women significantly shorter? It's in the negative side, so it's also one-sided. But you can also ask, are BD men significantly different from BD women in terms of height? So when I say different, it can be either taller or shorter, doesn't matter. So this is where two-sided test comes into play. Another example we can say is about study hours per week and exam score. So suppose you collected study hours per week and exam score for 1,000 students in Bangladesh. Now you can ask three questions. Number one is, are study hours and exam score significantly positively correlated? That means if you study more before exam, are you going to attain a higher exam score? So if the duration is given, it's one-sided. Also, if you say the opposite, so are study hours and exam score significantly negatively correlated? That means if you study more, is your exam score going to reduce? So that is also one-sided because it's a negative test. The final one is, are study hours and exam score significantly correlated? Now, this correlation can be positive or negative, doesn't matter. So in this case, it's a two-sided test. That's it. Okay. So these two variants are applicable for both parametric and non-parametric test types. So you can have a non-parametric test type, for example, z-test or t-test, and that test can be two-sided or one-sided. So there is one-sided t-test. There is also two-sided t-test. Again, in non-parametric case, for example, in Wilcoxon rank sum test, you are going to have unsigned or two-sided Wilcoxon rank sum test, and also there is signed or one-sided Wilcoxon rank sum test. We are going to talk about those in details in later videos. But just for this video, understand the idea about one-sided versus two-sided test. The final thing I want to talk about is paired versus unpaired, extremely important. So let's talk about paired first. Suppose you collected height of 100 couples in BD, couples. So here we are talking about couples. That means husband, wife. So the question is, does the husband earn significantly more money than the wife in BD? So this is actually 100 pairs, right? So there is 100 pairs of husband, wife, and for each pair you are looking at the data of husband income versus wife income, and you compare across these pairs. So if these data are paired, then that is paired. So let's talk about unpaired. So suppose we collected this will not be height, by the way. I have made a mistake here. This will be earning. We collected earning of 100 men and 100 women in BD. So the question is, do men earn significantly more than the women in BD? So now I understand that the earnings here are not in pairs. So there are 100 earnings, 100 income levels of 100 men and 100 income levels of 100 women. We are just comparing these two groups. That's it. So that is unpaired. The question is, do all tests have this paired unpaired variation? No, the answer is no. All tests do not have paired unpaired variation. Let me give you an example. So suppose we collected study hours per week and exam score of 1,000 students in BD. So I showed you this example before. In this case, you know that this is already paired because study hours per week and exam score will be for one student, right? So if you have 1,000 students, there will be 1,000 pairs of study hours per week and exam score. That means this will always be paired. This question of study hours and exam score being correlated will always be paired. Another thing we can think of is we collected tumor fraction. We collected tumor fraction data in 50 stage 1 patient, in 50 stage 2 patient, and in 50 stage 3 cancer patients. The question is the tumor fraction measurement significantly different between three groups? So the tumor fraction measured in stage 1, is it different from stage 2 and stage 3? Similarly, the tumor fraction measured in stage 2, is it significantly different compared to stage 1 and stage 3? And same question for stage 3, tumor fraction measurement, right? So if we sort of want to look at the results between more than two groups, I mean, if you want to compare the measurements or amounts or data between more than two groups, then we cannot really pair things up. So that is going to be always unpaired. So that is all about these different types of statistical testing. So hopefully you now can select the appropriate kind of testing for your case. So from the next video, we are going to talk about different types of non-parametric tests. We are going to describe them in detail, do the math, give you intuitions. So if you like the video, feel free to subscribe and share, and you can donate to our channel if you feel like helping our channel grow further. So thanks very much.